Hello. In this presentation, we will be talking about fats and oils, which are obviously materials that we find in our everyday life. Fats, for example, bacon grease, chicken fat, even the fat in our own bodies, and oils like corn oil and sunflower seed oil, various oils that we find in our everyday life. Turns out they're very much related to each other. It's just that the fats are solid and the oils are liquid. That's really the main difference between them. But before we can talk about fats and oils, we need to understand a few other kinds of compounds, specifically things called fatty acids, and more specifically, unsaturated fatty acids, and also saturated fatty acids. So, by the way, we'll also have to understand a compound called glycerin, which is an alcohol. And although you know what alcohols are, we haven't studied them as a separate chapter yet. And we also have to know more about what fatty acids are in general. So what are fatty acids? Well, they are carboxylic acids that happen to have 12, 14, 16, or 18 carbons. That's very strange because very specific numbers of carbons in order to be fatty acids. Now, carboxylic acids, again, compounds that you are familiar with because you memorized functional group, C double bond O with an OH attached to it. And then it's that OH and that double bond O together that make it a carboxylic acid. Kind of looks like an aldehyde or ketone, kind of looks like an alcohol, but it's neither because OH is on the same carbon with a double bond O, then it's a carboxylic acid. Okay, and fatty acids in specific have 12, 14, 16, or 18 carbons. Say that there are other carboxylic acids, but in order to be a fatty acid, it has to have one of those numbers, carbons. Okay, so let's start with some saturated fatty acids. So what's a saturated fatty acid? Well, that just means that there's no other double bond somewhere in this long chain. There is a carboxylic acid group. That's what this is. The double bond O with the single bond OH on it makes it a carboxylic acid. And the fact that it happens to have no other double bonds in it, no carbon-carbon double bonds, makes it a saturated fatty acid. This specific saturated fatty acid has a total of 12 carbons. So notice it has 10 CH2s in a row. That's CH2, 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 and so on. That's for a total of 10 of them. And then a CH3 on the end. That's that carbon right there. And a carboxylic acid carbon on the end. That's that carbon right there for a total of 12 carbons. So if you have that arrangement, then it's called lauric acid. So lauric acid is obviously not an IUPAC name for that compound. It's the common name for it. And we will learn when we get to the carboxylic acid chapter that many carboxylic acids have these special names that people use all the time. They're called common names. You've probably heard of formic acid. I know you've heard of acetic acid. Those are both special names for specific carboxylic acids. They're not fatty acids because they don't have a long chain of carbons, but they are carboxylic acids. This one happens to be lauric acid. By the way, that name comes from the plant called laurel. You may have heard of laurel leaves. It's a specific natural source where lauric acid is one of the main components of that particular plant. So that's why it's called lauric acid, because it comes from laurel. So this is lauric acid, has 12 carbons total. This one is myristic acid, and it has a total of 14 carbons, so 12 CH2s in a row with a methyl group on the end and a carboxylic acid group on the end. So this is the carboxylic acid group. So again, this is a saturated fatty acid because there's no other carbon-carbon double bonds anywhere in the chain. That's 14 carbons. This one is called palmitic acid, comes from palm oil, and so it's called palmitic acid. It has a total of 16 carbons, 14 CH2s, and you can count them here, and then a methyl group on the end, and a carboxylic acid group on the other end. So again, this is a saturated fatty acid. Total of 16 carbons is called palmitic acid. Now you might wonder, just to go off on a little tangent here, what about a total of 15 carbons or a total of 13 carbons? Well, those are perfectly fine carboxylic acids. They do exist. They're just not naturally occurring fatty acids, and so we don't run into them nearly as often as we do even numbered carboxylic acids, 12, 14, 16, 18. So this is palmitic acid, total of 16 carbons. And again, it's a saturated fatty acid because no carbon-carbon double bonds in the chain. And this finally is stearic acid, comes from beef tallow, the word steer in there. So this is the 18 carbon saturated fatty acid. So a total of 18 carbons, 16 CH2s in a row, a CH3 on the end, and a carboxylic acid on the other end. So this is stearic acid. So 4 naturally occurring saturated fatty acids: lauric, myristic, palmitic, and stearic. And you can remember those names if you want to learn, use a little mnemonic device, the word lamps, kind of like lamp oil. L for lauric, M for myristic, P for palmitic, S for stearic. Now let's learn about some unsaturated fatty acids. So here's an unsaturated fatty acid. Now there's going to be 3 of these. They're called oleic, linoleic, and linolenic acid. And they will all have at least one double bond in the chain. So this one is called oleic acid, which by the way comes from oil. And it happens to have a carbon-carbon double bond in the middle of this 18 carbon chain. So 18 carbons altogether. Notice there's 7 CH2s in a row. So these 7 are CH2s. Another 7 CH2s down here. That's these 7 down here. And then it has a CH3 on the end. That's that one there. And it has a carboxylic acid on the end. That's that one there. And it has a carbon-carbon double bond in the middle. That's the CH double bond CH. Notice it happens to be a cis double bond. That's not to say it couldn't be a trans double bond, and the compound in which that's a trans double bond does exist. It's just not oleic acid. It's a different compound. In fact, it would be a diastereomer of oleic acid, so it would have a different name. It's not called oleic acid. But it's not naturally occurring. Interestingly enough, the naturally occurring unsaturated fatty acid, 1 double bond, and 18 carbons altogether, is a cis double bond. And so here's the structural formula for it. Here's the condensed structure for it. So that's called oleic acid. The next unsaturated fatty acid is called linoleic acid. So they put this LIN in front. I'm not sure why that's true. Maybe because it comes from lanolin. Not sure. Anyway, it has a carboxylic acid on the end. And again, 7 CH2s in a row. And then a carbon-carbon double bond. So far it's just like oleic acid. And then it has another CH2, but then it immediately has another cis double bond. So CH double bond CH. That's this one. And then it has 4 CH2s. 1, 2, 3, 4. And then a methyl group on the end. So again, a total of 18 carbons. And you can count the 18 carbons here. So far, we've seen stearic acid has 18. Oleic acid has 18 with a double bond. Linoleic acid has 18 with 2 double bonds. Again, both cis, those are the naturally occurring forms of those double bonds. And finally, linolenic acid, just stick an extra N in there, has again the 7 CH2s in a row, just like we saw with oleic acid and linoleic acid. Then a double bond, then a CH2, so it's CH2 here, CH2, and then another cis double bond, and then another CH2 right there, and then another cis double bond, that's this one right here, and then a CH3 CH2. Sorry, there should be another CH2 in there. So for a total of, again, 18 carbons. So all of these unsaturated fatty acids, oleic, linoleic, and linolenic acid, are all 18 carbons. So those are the fatty acids, and you should know those names and structures. Then we get another important compound called glycerin. In glycerin, you'll notice I've drawn here a number of different times in different shapes and different ways of drawing structures, but they're all the same compound, just drawn in different ways. It's basically 3 carbons in a row, so it's based on propane, but each of the 3 carbons has an OH on it, so it's a tri-alcohol, or sometimes called a tri-ol. It has 3 OHs, but these are just regular alcohol OHs, and just happens to be 3 of them, and as I've said, drawn them in a number of different ways here. So that's called glycerin. And you may have run into glycerin before in your everyday life. It's found in some kinds of soaps called glycerin soaps, also sometimes, by the way, called glycerol. Same compound, just 2 different names for it, glycerin or glycerol. It's also used as a lubricant, very slippery material. Anyway, that's glycerin. By the way, it's a naturally occurring compound found in many cells. Now, what are fats and oils? Well, fats and oils are technically called triglycerides, which means that they are triesters of glycerin plus 3 fatty acids. So triglyceride is just a fancy word that means triester. So what is a triester? It's a compound that has 3 ester groups. And esters are, again, functional groups that you learn the structure of. So here we go. So notice this is glycerin. I've drawn it in this way right here. And then I've drawn 3 fatty acids here. So there's a carboxylic acid group and a long chain of carbons. So I'm just using a squiggly line here to represent any one of the fatty acids we've talked about so far. So it could be lauric, myristic, palmitic, stearic, linoleic, or linolenic acid. So just 3 different fatty acids. They may be different. They may be the same as each other. There's lots and lots and lots of different possible combinations here. But so three fatty acids and glycerin. Then notice that I've drawn it again here, but this time I've attached the fatty acid onto the oxygen of the glycerin. So this part right here comes from the glycerin. This part right here, repeated 3 times, comes from 3 different fatty acids. So what is this now? If you have a C double bond O with a single bond O and a carbon attached to the single bond O, then that's called an ester. So this is an ester group, this is an ester group, and this is an ester group. And so therefore this is a triester. If the 3 groups attached to the double bond O are long chain fatty acids, then we call it a triglyceride. You may have heard one of the blood tests that's very commonly done for people is to see what your triglyceride level is. This is what they're talking about, triglycerides. Now, what's the difference between a fat and an oil? Well, a fat, as I've said before, is all or mostly saturated. So all of these fatty acid groups are saturated, so they would be lauric, myristic, palmitic, or stearic. And they lie down side by side in a real life situation. These long chains all just kind of form ladders. And so notice that this one has a long chain here, and then also another long chain here, and another long chain here. So this would be a triglyceride molecule. Here's another triglyceride molecule with its second one pointing off in that direction. There's another one that's triglyceride pointing off in that direction. But the point is all of these carbon chains lie down next to each other and they form a fairly rigid crystalline material, which means that, and they're pretty happy that way. And that means it's going to take some heat to get them to go off and start moving around each other. So they happen to have higher melting points, usually above room temperature. And so if you take chicken fat and you cool it down, it turns into this kind of solid, greasy stuff. Same thing with bacon grease, it solidifies at room temperature. Lots of other fats do that. Now, what if one or more of those chains is an unsaturated fatty acid? Well, that was going to mean that there's going to be a kink in a chain like that right there. So what does that do? Well, it breaks up this regular pattern where these molecules lie down next to each other. It makes them much more likely to want to move around each other because they're not all stacked together like that. So here's an example of an oleic acid. Here's a linoleic acid. You can imagine if you had a linolenic acid in here somewhere, just takes a few of them, and those kinky spots right there tend to mean that the molecule becomes less and less likely to be a solid at room temperature. So unsaturated is good, polyunsaturated is even better. So you might guess from what I'm saying here is that somehow it's better if it's not a solid than it is if it's a liquid. So oils are much better for you to eat than saturated fats. And that's basically the idea of fats and oils. Thank you for your attention.